Okay, so we're going to start talking about the first type of reactions, which is the direct union reaction. And the direct union reaction is sometimes called combination or synthesis reaction. And the reason it's called like this because it takes place, or this reaction takes place between two or more elements or compounds to form a single compound. So it's very direct reaction. They combine together, forming one output, and that's it. We have examples like iron sulfide. We have forming from iron and sulfur, potassium chloride forming from potassium and chlorine, magnesium carbonate from magnesium oxide and carbon dioxide. So it's a very common type of reactions. In these videos, we'll see this is the reaction between potassium and chlorine, and this is reaction between iron and sulfur. So let's take a look at this reaction. First, before we start, I just want you to understand what's going on here. This is potassium spheres in a glass tube, and the spheres are exposed to chlorine gas. So chlorine gas is gonna flow over the potassium spheres. And what's gonna happen now is the reaction proceeds. Um, It's actually an interesting reaction. It's very quick and strong reaction. It produces a lot of heat, as you see here. It's gonna play in slow motion. This is another experiment recorded slowly. And you'd see that the potassium starts the reaction, and it goes quickly from one place to the other, and the reaction is going on and on until the potassium chloride is totally formed and there is no potassium available to react with chlorine. So this reaction is very spontaneous, is very exothermic, and it happens very quickly. This reaction is the reaction between sulfur and iron. I'm sorry, reaction between sulfur and iron, and you'd see he's putting them together as powders, and he's mixing them together well, so that he has a homogeneous solution of iron and sulfur. You notice here that no reaction took place, although iron and sulfur are mixed together well. So it's not like what happened in the potassium chloride case. You have them now mixed together, but nothing took place. So he needs now to initiate the reaction or start the reaction. So what's he's gonna do now? He's turning on the flame, and he is gonna put the glass rod in on the flame to make it hot. He's keeping it for a few moments until it gets red hot, and then he's gonna put it in the iron sulfur powder mixture. And when he does this, the reaction starts, and as you see, iron and sulfur are performing this reaction, forming the iron sulfide, which is the output of the direct union or the combination reaction. And you'd see now he's gonna pull the glass rod, and the mixture is sticking to it now because it is almost done reaction. So it's nice to understand how the reactions take place, and I want to relate the positions of the elements in the periodic table to this reaction that took place, or the two reactions. So iron is where's iron? Iron is should be somewhere here. Here, so this is iron, and this is sulfur, and this is potassium, and this is chlorine. So you see the locations of potassium and chlorine in the periodic table are very far from each other, and so the reaction was very spontaneous. And this agrees with what we said before, that this is the most reactive column, and this is the most or metal, and this is the most reactive non-metal. So the reaction is very spontaneous and quick. But here between iron and sulfur, it needed some sort of initiation to start. So this is a nice thing to notice. The second thing to notice is that the stability of the oxides. For instance, I'm giving examples of some outputs. For instance, the oxides decrease as you go from first to last period. So if you see the copper oxide, Copper oxide is a very strong oxide, and it forms readily in or spontaneously once copper is put in air. It forms the copper oxide very spontaneously, and it's very hard to reduce the copper. So you have to heat it until you reach more than 1000 Celsius, so you can reduce the copper oxide into the copper metal. While for silver, you can heat it only up to 200 Celsius to reduce the copper oxide. And for iron, it doesn't form oxide at all. And or I mean, for gold, and this what makes gold a noble metal, or a precious metal, because it keeps its shape, and it keeps its appearance without getting changed with the oxides or with the output conditions. One other thing is the outputs of the elements of different locations, again but here in the same in the same period, but in different groups. You'd see that for phosphorus chloride, the two elements are close to each other. So phosphorus chloride can be reduced into from pentachloride to trichloride at 250 Celsius. But for sodium chloride, which is different, or it's on more far away from the chlorine, you have to heat it up to 810 degrees Celsius. So this is something that we understand from before, but it's good to mention here as well. The second reaction is called the decomposition reaction, which is the opposite of the direct union reaction. For the decomposition reaction, you break down a compound into its original components, so it's the other way. And for the decomposition of different compounds is depending on its nature. For instance, acids either produce hydrogen or produce water vapor and oxygen. So for HCl, it produces hydrogen and chlorine, which is very intuitive. You can know that by yourself. Sulfuric acid would be broken into SO2, which is the sulfite, the oxygen and water vapor. Nitric acid into NO2, oxygen and water vapor. For bases, they produce the metal oxide and water. So calcium hydroxide produces calcium oxide, silver hydroxide produces silver oxide, ammonium hydroxide will produce ammonia and water. So this is how the bases are decomposed. For the salts, it depends on the type of salt that is used, um, uh, and based on the radical that is present there. So for instance, carbonates produce carbon dioxide and calcium and metal oxide. Bicarbonates produce carbon dioxide, metal oxide, and water vapor. This is actually very intuitive, as I said, and it's easy to predict if you don't know it by yourself. The nitrates give nitrogen oxide and oxygen plus the metal oxide, and for the sulfates will produce sulfur oxide and copper oxide. Again, you'd expect from this that or you see that you get the metal oxide and something else, if this radical has oxide. But of course, if you have like sulfur, I mean not sulfur, like potassium chloride, it will be broken into potassium and chlorine. So you don't always need to or expect to have the oxide and something like this. If it has oxygen, it produces the oxide. If not, then you would get the original radicals. This video is for the decomposition of calcium nitrate. It's a very nice video actually. He has here the salt, and he is exposing it to very high heat, and he has this wooden stick that is kind of like having some sort of flame in it. Just to understand what he is trying to do, he is decomposing calcium nitrate, which is a nitrate salt, something like this, and it produces NO and oxygen. NO is colorless gas, but it reacts with oxygen in air to form nitrogen dioxide. This is nitrogen monoxide. It produces nitrogen dioxide and oxygen. So what he's doing, he's putting this wooden stick that has some sort of flame in it, and the flame gets stronger, as you see here, when it's put inside, because of the oxygen that enhances the burning of the wooden stick. And as you see, as the reaction proceeds, more oxygen is getting out of the flame, or of the salt, and that's why the flame is getting bigger, or the fire is getting bigger. And this is the NO2, that is the output of reaction of nitrogen monoxide with the oxygen in air. So this is a nice thing to see, and this is like a good way of explaining it, because other salts might not produce colorful gases. Like if you have calcium carbonate, it produces carbon dioxide, which is colorless. So you need to have a litmus paper or something that will show you that this is something, or this is carbon dioxide. Um, the third reaction is gonna be the neutralization reaction. I'm gonna keep it for the next video, so I'll see you then, inshallah. Goodbye.